certain mathematical functions can be expressed more simply by expressing, say, x and y separately in terms of another variable. Like, let's say having x being equal to some r cos theta and y being equal to some r sin theta. You find that you have x being equal to a separate variable, y also being expressed in terms of another variable. The third variable here, as we can see, is our theta. Now, these such types of expressions are what we call parametric equations. Parametric equations. So some examples of parametric equations are like the equations of ellipses, parabolas, hyperbolas, and so on. You find that the x and y are always being expressed in terms of another third variable. So those equations are called parametric equations. Now, how do we go about differentiating parametric equations? So dy dx of a parametric equation is given by dy d theta, differentiating with respect to that other variable, over dx d theta. And how do you get the second derivative? D2y dx squared of a parametric equation is given by d theta of dy dx, all this divided by dx d theta. So these are the formulas you need to remember under differentiation of parametric equations. This is how you get the first derivative. This is how you get the second derivative. So if you're given a parametric equation, then you need to remember this. So I would like for us to take up an example and see how exactly we are going to go about it. So let's take up an example just right here. Let's say you're told x is equal to, a simple example, cos 2 theta, and y is equal to sine 2 theta. So what is your dy dx? Very fast. Our dy dx will be given by dy d theta. So dy d theta basically entails us differentiating this function with respect to theta. What is dy d theta? The derivative of sine 2 theta is 2 cos 2 theta. All this divided by dx d theta. Differentiating this function with respect to theta will give minus 2 sine 2 theta, guys. So that's it. You can simplify this and have cos over sine is the same as cot. So and have this as minus cot 2 theta. That is from the knowledge of trigonometry, guys. So basically, if you're told to differentiate a parametric equation, then this is how you're supposed to go about it. Dy d theta over dx d theta with respect to that other third variable. Okay, let's take up another example. Example 2. Let's say you're told y is equal to t squared minus 2 and x is equal to 3t minus 1. So you're being asked to get dy dt. Now dy dx. Now dy dx from the formula will be given by dy with respect to that other variable t over dx with respect to that other variable t. So what is dy dt, guys? If y is equal to t squared minus 2, dy dt will be equal to 2t minus 0. If x is equal to 3t minus 1, what is dx dt? Differentiating this, we will get 3 minus 0. So this is 2t and this is 3. So putting that into the formula, what do we have? Dy dt is 2t, all this divided by dx dt, which is 3. This is t. Let's take up another example, the last example. So given that y is equal to, so y is equal to 4 minus 4 cos theta, and x is equal to x is equal to 3 sine theta. So what is dy d theta? From the differentiation of parametric equations, the formula will be, sorry, what is dy dx? Not dy d theta, dy dx. So dy dx will be given by dy d theta, all this divided by dx d theta. So what does this give? What is dy d theta? You differentiate y with respect to theta. Differentiating this one will get 0. Differentiating minus 4 cos theta, we will get minus again. So that will be positive 4 sine theta over differentiating dx d theta. Differentiating 3 sine theta will give us 3 cos theta. So this is the answer, guys. We can simplify this to give 4 over 3. Sine over cos is tan, so we can write it as 4 over 3 tan theta. Okay, guys. So I want to close this and look at something else. Now, remember, I mentioned the second derivative, but we've really not done any example on it because we've not done, this is the formula for getting the second derivative in parametric equation. I want to first of all mention successive differentiation so that we can be able to know how exactly to go about differentiation of higher variables. So successive differentiation. We've really looked at so many ways of differentiation right now. So what is the meaning of successive differentiation? Successive differentiation basically means a continual differentiation, like differentiating higher orders, in higher orders. What do I mean by that, guys? So for example, if you're told y is equal to x raised to power 7 and you're being told to differentiate, the first time you're differentiating this, you're getting the first derivative, dy dx, which is equal to 7x raised to power 6. This here is first derivative. We can also call it y prime if you want. Now, differentiating this y prime, we will get y double prime, which is written as d2y dx squared. This is the second derivative. So basically it entails just differentiating this dy dx. So it will be 7 times 6 and then x raised to power 5. This is called second derivative. If we were to go on to differentiate this second derivative again, we will get a third derivative. So y, the third prime, this will give us the 3y dx cubed. And this is the same as 7 times 6 times 5. So 7 times 6 times 5. And our x is now raised to power 4. This is third derivative. So basically, guys, if you're being told to just get higher derivatives, that's how you go about it. Let's say you're told your y is equal to 2x raised to power 4, and then you're being told determine the 3y dx cubed. What is this going to be? Basically means you're going to differentiate this 3 times. So differentiate it the first time to get the y dx, the second time to get the 2y dx squared, the third time to get the 3y. So let's start. Dy dx will be, differentiating this, we will have 8x cubed. Let's go differentiating to get the 2y dx squared. So this will be 24x squared. Differentiating to get the 3y dx raised to power 3. This will be differentiating this 24 times 2. That will be 48x raised to power 1. So basically, that's how you go about successive differentiation of any term. So I would like to write the second derivative of the parametric equation so that we can go over it again. I said that if you're being told to differentiate a parametric equation, the second derivative, the 2y dx squared of parametric differentiation, is given by d d theta of dy dx, all this divided by dx d theta. Now let's look at a simple parametric equation. Let's say you're given your y is equal to 3 cos 2t and your x is equal to 2 sine t. And then you're being told to get the 2y dx squared. So first of all, we're going to get dy dx, and remember how to get dy dx of a parametric equation. So dy dx will be equal to dy d theta, all this divided by dx d theta. What is that going to give? Dy, it's not d theta, guys. It's with respect to t. Our variables have been given with respect to t, so this will be tt. So dy dt and dx dt. Now let's come here. Y is equal to 3 cos 2t. Differentiating this with respect to t will give minus 6 sine 2t over, to get dx dt, x is equal to 2 sine t. So differentiating this with respect to t, we will have 2 cos t. So that's our answer. We can simplify this. 2 goes here, 2 goes here. We have 3. Sine 2t over cos 2t is the same as tan. So this is the same as minus 3. This is it cos 2t? No, we can't combine this. This is cos t. So let me wrap this. This is cos t, and this other one is cos 2t. So I have minus 3 sine 2t over cos t. Now, guys, from trigonometry, I can be able to open this in terms of single angles. Let me write it over here so that we have like some space to evaluate. This is minus 3 sine 2t over cos t. I want to simplify it first before I go on to evaluate the second derivative. This is the same as minus 3. Sine 2t is the same as 2 sine t cos t. You can check this from the table. It's under trigonometry. And then all this divided by cos t. So this cos t can go with this cos t. Then I remain with minus 6 sine t. So that is my answer for actually it's supposed to be dy dx. Is it? So dy dx is minus 6 sine t. Now, from the second derivative, if you want to get the 2y dx squared, then it is d theta. So in our case here, the third variable is not theta, it is actually t. So in our case, it will be d dt of dy dx. We already have our dy dx here. All this divided by dx d theta, and in our case, it is dx dt. So what is this going to be? It will be d dt of dy dx is minus 6 sine t. All this divided by dx dt. And what is our dx dt? We already got dx dt and we got it as 2 cos t. We can do it again. X is 2 sine t. So differentiating, we get 2 cos t. 2 cos t. Then finally, what is our answer, guys? What is d dt of minus 6 sine t? That basically means, do you differentiate this minus 6 sine t with respect to t? And that will give minus 6 cos t. All this divided by 2 cos t. The cos t and the cos t can cancel out. So our final answer is minus 3 for that parametric differentiation, guys. So any question on parametric differentiation or successive differentiation, guys? Is there any question, guys?